Hello, everyone, and welcome to OpenObservability Talks. I'm your host, Dotan Horvitz, and here at OpenObservability Talks, we talk about anything DevOps, observability, and open source. So may the open source be with you. I'd like to thank our sponsors, Logs.io, the cloud-native observability platform. Logs.io takes the best-of-breed open source projects, such as Prometheus, OpenSearch, and Jaeger, and offers them as a unified observability platform built for scale. For those joining the live stream on YouTube or Twitch, feel free to share questions and comments on the live chat. That will definitely make some things more interesting for us here and can get your answers from the best experts on the domain. And with that, let's move on to today's episode. Back in 2021, I think, I dedicated here on the show an episode on continuous profiling. I said back then that profiling is set to be the next major telemetry signal in observability. And in fact, since then, there's been a growing interest in profiles, startups that focused on this domain, large observability vendors that got into this domain, even acquiring some of these startups, and as we'll hear today on the show as well. And perhaps one of the most important milestones in this domain, a significant step, was when OpenTelemetry project decided to add profiles to its core signals and formalize the open unified specification for that. Today, I'm going to hold a special panel-style episode to look into the state of profiling and into the work of OpenTelemetry in that regard. My guests are both members of the OpenTelemetry SIG Profiles, the special interest group founded for this topic, and both are from major vendors in the observability space, Datadog and Grafana Labs. And I'd like to invite them into the stream. Felix and Ryan, hey, how's it going, folks?
Yo, hey. How you doing?
I'm fine. Great to have you here. And instead of me introducing, you have very impressive resumes. So let's go around the table, as they say. Let's start with Felix from Datadog. Can you introduce yourself?
Yeah. Hey, I'm Felix. I'm in Berlin, Germany. I'm a senior staff engineer at Datadog, where I work on the continuous profiling product. And I also contribute to profiling in the Go runtime upstream. And as you mentioned, I'm a member of the special interest group for profiling together with Ryan here.
Thanks. And we have Ryan Perry here with us. Ryan, can you say a word?
Yep. Yeah, what's up, everyone? I'm obviously Ryan. I work for Grafana Labs now. I was one of the founders of / maintainers of Pyroscope, which was an open source continuous profiling project that we started and then turned into a company about 3 years ago now. And and so we've been building profiling there for a long time, and then ended up joining Grafana Labs to better sort of integrate with the rest of the telemetry signals out there.
Great. So amazing to have you. And there's maybe a teaser for the episode, a major milestone that you folks achieved just last month with the merge of a big OTEP, an extension proposal that formalizes continuous profiling. So definitely lots of fresh, hot off the press updates about the milestones, and we'll talk about it in a second. But let's start first. As I mentioned, I had an episode here with Frederic from Polar Signals, also a company behind the Parka project, open source project, another open source project in the profiling space. But a lot has changed since then. I've been following closely, but you're the expert there. So maybe just to get a sense of what we've seen in the past year or year and a half in terms of changes, in terms of adoption, in terms of use cases and reaction in the market and amongst your users. Ryan, would you like to start?
Yeah, sure. I would say that a couple years ago, profiling is not something that's new. It's something that's been around for a while. But as a lot of kind of advancements have been made, the Go runtime made profiling very popular there. Profiling is pretty popular in the Java community, and it started to expand even more. A lot more people became more familiar with this idea that more closely aligns profiling with logs, metrics, and traces, where rather than getting them in some sort of ad hoc manner, you can collect them, collect profiles continuously and be able to query them, correlate them with other signals, and that kind of thing. And so I would say that's the biggest sort of shift that I've seen happen over these past couple of years, is that people are wanting to have this profiling data and be able to store, collect, and analyze it in the same way that they do their other signals that they collect.
Yeah, and I think this is a very important point that you mentioned, because I think you said profiles have been around for quite some time, but mostly people used to think about profiles in the context of performance and cost related, very much isolated in a way. And I think or what I've seen in the market, like looking it into as part of the broader observability, I think this is the trend that was very interesting. Maybe Felix, if you want to give your perspective on the trends in the market with that regard.
Yeah, I can definitely echo a lot of what Ryan said already. I would also say that even so historically, profiling was already focused on cost and performance. There has been a renewed interest in especially the cost angle, given the economic situation that a lot of the tech industry has faced. So the classic profiling has become more important just in the last year even. But in parallel to that, there is now interest in what else can you do with profiles, especially with signal correlation with tracing. So it's become very common now that profilers can collect span IDs and trace IDs when they take samples, and then you can take a individual request and reason about the resource consumption of that request. And going even further, when you also have off CPU information about where the request was spending its time that might not have been captured with dedicated spans, then you can even say with confidence that you know what caused the latency of a particular span inside of an application. So yeah, that's another big trend that we're seeing. And lastly, I think a lot of people, now that profiling is becoming more commonplace, realize it's also a very powerful signal during incidents. So being able to look at, hey, what did my profile look like before things went wrong, and how does it look like now? Maybe an error path is now lighting up red hot in the flame graph and tells you what's going on. That has also become a use case that's becoming more popular, I think.
Yeah, and for the listeners who are less familiar, flame graph is like the classic visual, the type of visualization for continuous profiling. Although we'll talk about more options to leverage, but this is like the classic thing that we used to stare into analyze. And you mentioned something interesting. You talked about the trace data and doing that, and I think this is going back to what I talked about, the broader observability and seeing the core values and correlating it with the trace data. I think this was probably also the incentive of also bringing it into OpenTelemetry. This initial, the basic tenet that when you correlate the signals is where the value lies. And then examples like slow trace, is it CPU related? Is it network call? Maybe things that people even less think so, like mutex contention, things like that. So just again, curious to hear what kinds of use cases and patterns you see arising from the industry and from the community. Ryan, do you want to take that?
Yeah, sure. Yeah, I mean, I would say the tracing is one that I think most naturally makes sense, that people can really understand that you have this trace span. A lot of times, depending on how you've instrumented your code, you can understand certain things, but you can only go so far down the rabbit hole before you have to start sort of guessing of why was this particular trace span slow, or why was this trace slow, and then that's where profiling comes in handy there. But I mean, I think it's very the ability to the same way you can correlate traces with logs and metrics as well. The ability to be able to see a spike in CPU utilization or out of memory errors in your logs, and be able to go from that to understanding the specific code that is behind it. You see, instead of just seeing that there's a spike, you see that there's a spike, and that's because X% of your time was spent in this part of your code, and Y% of your time was spent in that part of the code. And then same thing, you're debugging some out of memory error, and you can see exactly the memory profile and which objects were taking up that memory. And so it fits in very nicely with tracing, but we also see a lot of kind of potential for profiling, kind of finishing some of the story, answering some of the whys or the root causes of other issues that may be surfaced by other signals first, but whatever it is, being able to just kind of generally ask a question of your telemetry observability data and be able to answer that question, whether that's via profiles or some combination of profiles and something else.
Yeah. Felix, do you see other types of, in addition to what Ryan said, other types of correlation, other types of indications that you can get out of this valuable signal and the correlation of the signal with other signals?
I would say Ryan covered most of it, especially the memory and out of memory debugging use case is definitely a very big one. Correlation with logs can sometimes be interesting. There might be a log that says, oh, some data had to be dropped because the system was overloaded. And then you can actually look at what was the load on the system really at that point of time. And even further ask, why was the load high for this potentially brief period of time? So that's something you can do with profiling. And similarly, metrics, you can do time correlation if you know which instance was producing the metric and you have the profiles from that same instance. There's a lot of stuff you can do.
And in terms of, we touched the visualization, the flame graphs, but what else can you see, Felix, in terms of how can we use this precious data in terms of types of making it more accessible and easily to analytics, to lend itself to analytics type of investigations?
Yeah, there's actually probably a very interesting line of thinking around turning profiling data into metrics, because certain things that you would like to measure, you can only measure with profiling. A good example would be the amount of work done by the garbage collector on Go. There are runtime metrics that try to capture this already, but the problem is that they are essentially just timers inside of the runtime that measure wall clock time that's passing while the garbage collector is doing stuff. But the Go runtime doesn't have information about the operating system's scheduling of the threads that the Go routines are running on, including the garbage collector Go routines. Being able to see exactly how much CPU time, not wall time that might be the same as CPU time is going into GC is something you can do with profiling, and you can in theory take that and turn it into time series data that's much easier to consume, and you can very directly see, hey, did my change make it better or worse, and how much is it really, especially when there's high load on the host in general, which can cause these scheduling artifacts that I was hinting at here. Yeah,
makes sense. And when you talk about profiling, we talk about it as a one type, but essentially there are different approaches for profiling, right? Essentially, so the runtime, the full host. So can you share a bit just before we get into the relevant considerations within OTel, just to set the stage in terms of the terminology? Ryan, do you want to share with us just a bit about these schools of profiling?
Yeah. So so there's definitely many ways to get the profiling data. Each one's have their different pros and cons. One approach is using sort of the SDK approach, where you're doing pip install something, gem install, npm install, that type of SDK, adding it to your application. I would say that's typically leans more towards developers who have control over which libraries are added to their applications. But then there's also a method of getting profiling data, often via eBPF, but not necessarily always, where you don't have to necessarily change the code in your application, and instead you can get that profiling data via other methods. And that is typically associated with kind of whole system profiling, or being able to kind of add, it's operating at the kernel level, and then being able to get that profiling data in an efficient and, I guess, arguably less invasive way of getting the profiling data.
Yeah, and it's very interesting that really eBPF seems to be getting a lot of attention. Actually, even I think today or yesterday, I posted some stats about the how the adoption of eBPF, and specifically within the observability space. I saw a nice analytics on different projects, including, by the way, projects that you're involved with, and it's very interesting to see the graph, even on the GitHub traffic, to see how it goes up. I just shared that with the audience as well, and it will also be obviously part of the show notes for those who are on the podcast. But so this is sort of the schools turning to the runtime profile approach, sort of the deeply embedded in the programming language on the one hand, and then the full host. Felix, can you tell us a bit about what's the pros and cons for each, or what lends itself better to what types of analytics out of that?
Yeah, I would say that the eBPF profilers or full host profilers generally are focused on CPU profiling right now, which is one type of profiling. And the trade-offs that they're making there is they can see everything, but they are the runtimes that are being observed are not aware that they're being observed by an outside profiler. And so the challenge there is when you create profiles, you want to get stack traces from the applications. And to get a stack trace from a runtime like Ruby or Python, you need to understand how the interpreter actually represents the stacks internally. And you can do this in eBPF and encode it, but it is subject to change. If the Python or Ruby runtime evolves, then your profiler might start producing incorrect data, or it realizes it shouldn't be producing data. So it's like, oh, I'm not going to give you stack traces now because this is a new version of this runtime that I haven't been updated for yet. And yeah, similar issues exist with JIT compiled languages like Java, where it's even harder. Symbols are another challenge for the eBPF side because a lot of things that you do want to observe and where eBPF profiles are actually really strong is native binaries compiled with C, C++, Rust, and these languages that play a big role. But oftentimes in production, they're shipped without symbols. So you need to start a secondary pipeline of sending these symbols from your CI processes where you're building your images and gets this data up. So the big advantage for CPU profiling is you get to see everything right away, but it's a little bit more precarious on the interfaces on getting the data. Things might sometimes break or need constant updating, needs constant maintenance, and symbols are a challenge. And runtime profilers generally, yeah, they don't have those same challenges. They're inside of the runtime. They get the symbols all the time. And there are disadvantages. You have to deploy them to every application. So you have to go out and upgrade your whole fleet, which can also be a big maintenance burden, especially for the user. I would say for the eBPF profilers, it's more a burden for the producer of the profiler to keep all of this up to date, whereas on the runtime profilers, it's a little bit more on the user. But it's a one-time cost. You install them once, and then it works. And where the runtime profilers really shine is advanced profiling types, stuff like memory profiling around allocations, live heap and live objects, mutex contention, go routine profiles. These things are not theoretically impossible with full host profilers, but the current techniques that are being used require context switching between user space and kernel, which in some of the hot code paths like allocations would probably be prohibitive, or at least I haven't seen it figured out yet. Conceptually, it's possible, but it's not been done as far as I know.
Yeah, and I think it's important to mention because people tend to think about the classic, like we talked about before, the out of memory, the CPU spikes, things like that. These are the classic things that people think when talking about profiles, but there are many other values, and you mentioned just a few, like the mutex contention, like heap analysis and things like that. People need to bear in mind that it's much more powerful than just CPU and memory. And then obviously we need the right instrumentation to make sure that we get the relevant information. And also we think about profiles as a young signal, and obviously it's maybe lots younger than logs and metrics. Still, it's not brand new, and we have quite a bit out there to build upon, both in terms of existing programming languages and their built-in mechanisms. We have built-in capabilities within kernels and operating systems. We have formats that have already been established. So we're jumping into, and we'll move soon to talk about OTel, but so there is some history and some already existing framework that we need to address. Do you see that? How do you see the landscape that preceded what we're now doing with OTel? Ryan, if you want to address that.
Yeah, I can start there. I mean, I would say definitely the most popular one is pprof. Pprof is pretty much synonymous with the Go language, used very heavily there. It was created, I think, initially by Google, and so it's a very efficient format for profiling data, and one that people tend to be pretty familiar with. But in the Java ecosystem as well, you have JFR, and they have their methods of producing profiling data as well. And so I would say those were the two main ones that we were, trying to draw inspiration from. We started this group 2 years ago now, almost exactly at KubeCon back in Valencia. And so basically when we started it, we wanted to make sure that we were, drawing from what already existed and not sort of reinventing the wheel, but making sure that we were making improvements there. And so I would say that those were the two main ones that we considered in terms of the formats themselves. But there's many other, like there's a more basic format that's just like collapsed or folded that exists, that a lot of the language profilers that exist, PySpy, RBSpy, other profilers that are out there often emit sort of like a common one there. And so we're trying to find a way to unify all of those and have a standardized format that everything will know how to produce, and things that are ingesting those formats would know how to ingest.
Sounds good. We have a question from the audience. We talked about flame graphs before and visualization. So the question is, flame graphs is a great profiling tool that seemingly integrates with tracing. What other types of profiles will be useful in future to have a complete overview of production workloads? Felix, do you want to take this one?
Sure. I would say that one new type of profile visualization that is resonating with people these days is a timeline view, where you try to show each thread or each go routine in the program and then show what it's doing over time, if it's on CPU, if it's on CPU, what it's doing there, for how long, and if it's off CPU, what it's waiting for. Is it waiting for a timer? Is it waiting for the network? Is it waiting for a mutex that it's getting blocked on? And being able to jump to that level of granularity on an individual thread or go routine is very valuable. And going even further, getting the connections between these go routines and how they communicate, like this go routine here did something that unblocked this one over there. I think that's a powerful new area for exploration for profiling in a continuous setting.
Yeah, sounds good. And before, maybe one last thing, I talked about the trends and talked about the growing interest in this field in the last couple of years. And I think, Ryan, you're actually bringing the entrepreneur experience of actually deciding that this is the venture you want to delve into. You actually started a venture, a startup, all around squarely around continuous profiling, which had a very good happy end, joining in with a very established and very well-known vendor in the observability space, monitoring and observability, Grafana Labs. Everyone knows Grafana as the open source tool, and obviously many others, Loki and Tempo, and now obviously your piece of the ecosystem. Can you tell us about this maybe point of choice, because you've sort of seen the market trend also from the entrepreneur and the business side of things? How did you see that embracing by the market and by the players in the industry?
Yeah. So me and my co-founder Dimitri, we had worked together at a previous company actually, and we were using mainly RBSpy was the one we were using pretty heavily. And we found a lot of value that we were getting from taking RBSpy, and we built sort of a hacky version of what eventually became Pyroscope. And we saw that there was like a lot of value. It's kind of a long story, but basically we were doing a bunch of like compression stuff at this company that we were at, and we didn't realize just like one basic thing, that it was like a specific line of code. There was a library we were using. It was set to like the maximum level of compression, consuming a ton of CPU. It was one tiny one-line change that ended up saving us like 20% on our compute bill. That was just like, for a small portion of what we were doing. But it was kind of that realization of like, having that, extra view of what your application is doing resource-wise, that we were like, this is a really powerful thing that we think people would really like if you can find a way to collect and store that, or we already were collecting it, but to store and query the profiling data efficiently. And so at that point, 3 years ago, there were a couple of different profilers that were out there. Datadog definitely had one that was, I would probably say, the most popular, and Google obviously had one as well. And so we kind of saw that there was a trend, as with databases getting created for these different signal types. The way that there was, Prometheus for metrics, the way that there was, different databases that were created for traces data. And there wasn't one that really existed, at least in the open source world, for profiling. And so that's what we set out to create. And once we created it, we saw a lot of traction. A lot of people were really excited. Had some cool, Hacker News, interactions with people. And I think that's like a good pulse of what people are interested in. And we saw enough interest that we decided to pursue it, at least as a project. And we're lucky enough to get some, VC funding and that kind of stuff. And we're able to turn it into a business and, continue growing. But the last thing I'd say is that, as we were growing, we did see that there was a lot of interest, not just in profiling as an isolated signal, but in the way that OTel is moving towards joining all these signals together. We didn't really see that we felt like there was a higher ceiling for the value that profiling could provide if we were to kind of join it into a suite of other products or have a way of doing that. And so that's why we ultimately decided to join Grafana Labs and better sort of align with the OTel model as well, and how all these signals kind of correlate with each other.
Yeah, that's quite the journey, and I've been following and cheering from the sidelines. It's great to see that, and so that's a good segue to OTel. So you mentioned before, Ryan, that a couple of years ago, when the OTEP was proposed, the initial desire to establish a formal SIG, a special interest group dedicated to continuous profiling, to look into how continuous profiling should be part of OpenTelemetry. And since then, there's been so much that has been done. And I think that the most fundamental questions that we started with as a community, with your leadership, of course, was how we should even go about doing that. If I remember even the basic questions about whether this should piggyback on existing modeling of the logs or other existing signals, or whether it should be from the ground up a whole new one, and whether in terms of the data model and specification, whether it should be derived from an existing standard. You mentioned the pprof before and so on, or should it be a whole different beast? All these decisions, the fundamental decisions, even before implementation. Maybe Felix, do you want to share with us a bit about what the path that has been taken with OTel on this regard?
Yeah, sure. I think, as you alluded to, there was initially discussions on sort of prior art when it comes to formats, pprof and JFR being the two main formats we looked at and discussed. But there's a wonderful website by Mark Hansen called Profilerpedia that is trying to be a comprehensive resource for all the data formats and profilers out there. And as of today, I think it lists 162 data formats and over 240 profiler implementations. So there's certainly no shortage of formats that we could have considered. And we did not, in fact, have time to consider all of them. And we did consider the conundrum of adding yet another format to this mix, of course. But yeah, that was our starting point, just taking inventory of what's out there and going over it. And I would say a lot of the initial discussion was, as you said, about should it be its own signal type, but in the end, that was sort of where most of the profiling special interest groups saw things going. Because with logs, for example, you could argue that everything is a log. You can turn logs into metrics or traces if you try hard enough. So that argument, of course, makes some sense, but there is a reason why these other signal types have been created. And so for profiling, there were special considerations as well, essentially around the volume of data being produced, the number of samples, and how efficiency is a very important aspect of it, because the proposal of I'm going to give you something that you can use to make your code faster, but it's going to actually make your code slower is not a great value proposition. So the general sense in the community is that like 1% is a good threshold of CPU, memory, latency, overhead. And if you want to hit that, you do need to think about the format very carefully as well. So we had discussions on stateful versus stateless formats as well. I don't know if Ryan wants to talk about this a little bit, or if I should continue on that train of thought.
Yeah, I mean, I don't know how deep we want to get into it, but yeah, the conversations definitely go really deep because there were so many that were out there. But ultimately, we wanted to basically balance. I will say that we were I believe the first like signal that kind of came out of so logs, metrics, and traces were something where a lot of the technical committee and governance committee from OTel was directly involved in the creations of those signals. Profiling was the first signal where most of the group had come from, sort of outside. And it was also, not only a milestone for just like the greater community, but for OpenTelemetry as well, and sort of being able to accomplish its goal of being something that is able to expand and grow with the community and the community interest. On the other side of that, the approach that a lot of the profiling SIG had taken was, not necessarily in line with what OTel wanted to do. So I would say that a lot of those conversations, for example, of statefulness versus statefulness, was kind of around. So how do we align with the way that the other signals have done, with the way that the collector works, with the way that the model that a lot of people are familiar with OpenTelemetry, and how do we balance that with the performance that we want to achieve? And so, without getting too deep into the weeds there of everything that we considered, and as part of that debate, I would say just from a high level that it was mostly focused on, making the proper trade-offs to align with what the community wants, align with how OTel has worked before, but also not be totally constrained to a single way when it made sense to kind of deviate and do things a little bit more efficiently for profiling.
And we talked about the standard, so I fast forwarding to the decision that has been made, which was essentially to go with a pprof inspired standard, or what I think you call it pprof extended in a sense. So, Felix, do you want to say a word about what's the decision there in terms of the what is this pprof extended sense that OTel went with?
Yeah, so we ended up with what we now call pprof extended, and that was merged in the OTAP as a result of various lines of thinking. But ultimately, what the collector SIG felt passionate about was that the profiling signal, when it arrives in the collector, behaves like the other signal types, which means the data is deconstructed into this internal data format of the collector called pdata, and then the processors that come after the receivers can do some interesting things with the data, maybe filter out things, or maybe other ways of aggregating or similar things. And then they can export the data in all kinds of new formats. And to do that, we needed a format that was fully specifying everything that needs to go in the flame graph. And pprof was the closest, or really the only choice that we could base off, because JFR is a great format, but JFR is not a standardized format. It is basically not documented, and it only lives in the runtime internals of the Java platform. So it was not an option by any means for adoption. In fact, I don't think the Java platform people would want it to be adopted, because that would make them lose the ability to change it in the future, which is still important to them. So pprof was the one that we had at hand, and that we agreed was pretty much what we wanted. There were some tweaks that we were interested in doing. And so we made one attempt, and Dimitri from Grafana did a lot of work on this, to create a format similar to pprof, but not compatible with pprof. But then we looked at the result and concluded that it's still close enough to pprof, so it would be nice to be actually compatible. And a second iteration was done that then we now call pprof extended, that essentially takes the original pprof protobuf definitions, keeps them as is, and adds new fields to them that are either useful for OpenTelemetry purposes, such as signal correlation, meaning first-class connection between trace IDs, span IDs, and profiling samples, which in pprof you could do before with unstructured labels, key-value pairs, but that was never really a great way of doing it. And another major improvement to pprof is the ability to reuse stack traces. In pprof, when you have what they call a sample, which is really an aggregate of multiple samples and a counter of how many times it has been seen, that has the stack trace directly embedded in it. And if you want to tag it with labels or trace IDs or span IDs, you basically have to make another sample. But if that has the same stack trace, you're now copying that same stack trace multiple times. And that is something that has been optimized in the new format that will hopefully lead to appreciable gains, especially for compression on the wire.
Yeah, so, and then we should say, we mentioned before, pprof originated from Google. As far as I know, Google still is the entity behind this, so it's not a vendor-agnostic specification, but it is a specification in many senses of the word. I'm just curious if there is any intent on actually making it formally part of a foundation or something that will allow for a more closer collaboration between the OTel extended pprof extended and pprof, or is that not yet under discussion? Ryan, if you want to take that, I don't know who has the intel on that.
Yeah, I'll take it. I mean, obviously, that's a huge decision, and and obviously, we would, love for that to be an option for the future. I would say, that if you actually look at the first PR, that they had mentioned wanting to be able to work more closely with the format. No, I guess commitments have been made as far as that goes. And so we've just been operating as if that is not going to be the case. And that's why we wanted to make sure that that the format that we came up with was still compatible with pprof, but not necessarily, but it's still controlled in the OTel sense, so that we can, add and extend and do whatever we want to that format. Who knows down the road? I definitely think that it is a possibility, but like I said, making promises on behalf of Google is a pretty major thing to make. But I'm
just wondering if a discussion has been started. Obviously,
absolutely.
Receptiveness from Google's side to consider or where it stands. But
yeah,
I think you
absolutely.
fairly answered where things stand, and sounds like it's early on that. But so as far as you're concerned, like, is OpenTelemetry, just putting it in plain words for us, plain common users, is OpenTelemetry essentially forking pprof, or what's the way that you see it going forward as currently stands? Ryan, sorry, that's a follow-up question on the same. So do you see that as a fork option, or how do you think that, based on these assumptions that you mentioned, that it's not on the table at the moment?
I would, I guess it's kind of a semantic argument. Yeah, I mean, I would say in a way, yeah, you could say that. I don't know. I'm curious how you would describe it, Felix.
I would say right now it is a fork, but it's a very friendly fork in the sense that there has been a lot of discussions with folks at Google. In fact, Alexei, who's currently the maintainer of the pprof project for Google, has been heavily involved in the debates and design decisions that went into pprof extended. So I would say there is still a chance that this will converge with the pprof project upstream. But as Ryan was saying, it's not guaranteed. A lot of people at Google probably have a vested interest in being part of this decision, and we can't force that timetable. But everything has been done from the signal or special interest group to put the new signal format in a place where that could happen in theory, and we hope it will happen.
Sounds good. And another question, Felix, about, so are we looking at discrete events, or do you look at pre-aggregated for trends over time? How do you see, because these are sometimes different cases, also talking about the analytics type that you do in the back end. How do you see these aspects?
Yeah, that's a good question. So pprof, as mentioned earlier, is more on the aggregated side of things. So you get a stack trace and how many times it has been seen, and it's essentially just a list of that. That's a pprof. JFR is a really event-based format where each sample gets represented as its own event with its own metadata. And pprof, through the nature of having labels, can be made into an event-based format. It's just not the sweet spot for it, but you can slice and dice it into even single event level. In fact, you can use the labels to add individual timestamps to it. It's not the most efficient way to put timestamps on profiling samples, but it is doable and it does work. For the OTEP, we have currently still, I believe in OTEP 239, a field called timestamps that we left in there that would improve the situations over label by essentially saying if you've seen a stack trace multiple times with, I believe, the same trace and span ID or no trace and span ID, then you could just provide a list of timestamps at which the sample has been seen, which is a more efficient representation than splitting it into several samples, each with their own timestamps. So that's something we're going to experiment with a little bit more now that we're moving to a more experimental phase with the signal. But generally speaking, my feeling is that we're mostly in aggregation format at this point. That's going to be the main use case for OpenTelemetry profiling in this iteration.
Interesting. Although I have to say that I do see some interesting use cases also for the event base, but I definitely understand why the starting with the aggregated one it makes sense. And going into the use cases, maybe Ryan, if you can touch about that. So looking now at the processing side, so the OTel collector essentially gets the trace data, and just like any other signal, it has the flexibility to put in different types of processors to do all sorts of aggregations and filters and sampling and so on. What does that look like when we talk about profile data? What kinds of processing use cases do you see for profile data?
Yeah, so there's a lot that you can do there. I guess one of the benefits of the architecture of the collector is that people can kind of build what use cases they want, build various receivers, processors, exporters. The main ones that we've been thinking about, and the ones that we've kind of gotten feedback from over the time that we've been investigating all this, has been one, being able to do some sort of sampling. So, the collector is, a great pace to be able to, decide, I guess, kind of how much profiling data you want to collect and be able to make decisions there. The other is doing some sort of either filtering out things or filtering out like tags or labels, or adding tags or labels. The actual method that we do that is something that we're still kind of figuring out what the most efficient way is, and exactly how those labels will get either filtered out or added. But being able to do that in the collector is something that a lot of other signals have make use of. And then and then one thing that is probably down the road, but also making decisions on what to do with symbols is something else that also might be a decision that at least involves the collector, and how we handle those. But I would say those are kind of the main things that we've talked about as sort of the initial version, kind of the MVP of what we want the beginning of this implementation to be able to do. And then we're going to kind of one of the things that we really want to focus on at this stage, though, is getting a lot of feedback from the community, and being able to understand exactly what the community wants to be able to do with their profiling data, and make sure that we both align and enable them to be able to do that with what we're doing right now.
Which is a great comment. So let me join you on this one. And we definitely, I want to personally call on all the listeners on the different channels. If this is something that you're passionate about, if this is something that you've explored or considered, do share, because this is a work in progress, as you hear, and all your feedback about how you would like to use that, and maybe how you started experimenting on using, maybe do it yourself that you invented in-house that we can learn from. Anything of that will be much appreciated. That at the end of the episode, we'll mention how to touch base with the SIG and join the conversation. So definitely looking forward for feedback on that. And you talked about the MVP. So let's talk about the reference implementations. Obviously, we talked a lot about the specification, data modeling, and pprof, and pprof choice, and also protobuf modeling and everything. Let's talk about reference implementation, which is probably what the vast majority of the users out there will is the point where you will start engaging when they have something to deploy and play with. And I know that your colleague Dimitri at Grafana Labs, Pyroscope co-founder, has been working on is the sort of reference implementation MVP for the collector, for obviously collector pipeline for ingesting and processing continuous profiling. So what you've described, is that what the first reference implementation will be?
Yeah, it will definitely be something along those lines. Like I said, it kind of depends on some of the feedback we get, but yeah, as far as we can tell, those are the ones that we think just make sense even, before getting a ton of feedback just from our various the maintainers and contributors to the SIG that we've sort of determined that we would want to do with profiling data, and then we'll kind of expand from there. So I would say, that's on kind of the collector side. One thing that we are planning to start now that we have this format that we can use is the reference implementation. So recently Elastic proposed to donate their profiling agent to OpenTelemetry for this purpose. They have one that's in that camp of the whole system profiler, leveraging eBPF very heavily. And that was received very well, at least so far. And so we're in the process of evaluating that and determining whether or not that will accomplish all the various goals that we have. I believe it was Splunk who donated a .NET sort of SDK version to the .NET SIG or .NET instrumentation group, or in the process of that. Go is obviously one that is very friendly to the OTel world. A lot of people are very familiar with Go, so we want to definitely support that. And then, like we said, Java with JFR is very popular as well. So I would say those are kind of the ones that are in progress right now. But also, yeah, we're hoping to, as much as we can, parallelize things and work with the various language maintainers and that kind of stuff to get, Python, Ruby, other languages. We want to be able to do that as well. While we do want to offer the path of the whole system profiler, we also, for people who aren't able to use that for whatever reason, whether it be security reasons or having the proper kernel version, stuff like that, being able to have alternate methods of being able to send this profiling data, we want to support that as well. And so we're kind of focusing on the ones that we know the best and that we have the tools to be able to do, and then hoping we can rely on the community for the for the rest of it.
Sounds good. And Elastic's suggestion for donation looks very interesting. For the listeners, actually, this is another interesting example of a startup that was squarely focused on continuous profiling, and then was acquired by a very prominent player in the observability space. So I think they were called Optimize, if I'm not mistaken.
Yep.
And to be fair, I actually wanted a member of their team to also join us on the panel, but it didn't work out in terms of timing. But very, very interesting, and looking forward to seeing how this donation works through. But if so, this will provide a very mature implementation. It's eBPF based, so we talked about full host profiling. So we'll have like out of the box implementation that users can start with. So this is definitely a great call out for Elastic for this great donation, and that will push things forward. And we talked about reference implementations in several languages also. So if you are in one of these languages, and if you're involved, whether Java, .NET, Go, these are the prominent ones at the moment. So definitely any feedback also on that side of the instrumentation, especially the deep instrumentation, deep integration into the runtime profiling requires people that are deep in the details of these languages. So well, again, appreciate any feedback that you can share. We wanted to talk about maybe look ahead into what's planned. So there was a big milestone. Maybe a word about the milestone that has been achieved just very recently. The merge. Can you explain in plain terms for those who are not in the intricacies of the CNCF structures what that means and where the SIG resides at the moment with this? Felix, if you can take that.
So the merging of the OTel 239 is very exciting. It was something the Signal group has been working towards for a long time. And the process for that was creating alignment within the group, which took a lot of discussions and a lot of prototyping and a lot of things. And then it also required 4 approvals from people, I believe, from the technical committee of OpenTelemetry. So we had to go and get those sponsors to approve the pull request. We had to get feedback from other people outside of the profiling group as well. And once we had the sufficient number of people who approved, as well as addressed a lot of feedback, there were a lot of comments on that pull request that were responded to. Once all of that looked good, that's the point where the pull request was eligible for merging and got merged, which means I think we're officially now in experimental status with the Signal.
Yeah, and I
So
believe
now it's
that
official. Yeah, sorry, go ahead, Ryan.
I was going to say, and I believe the stages, it's like draft, experimental, and then I think stable comes after
Stable.
experimental. And so now we're in this experimental stage, which allows us, it means that nothing is final. And so, a lot of the decisions, not everything was resolved in those PRs, but, we got to a place where we feel reasonably comfortable with it. And now it's sort of the kick the tires phase where, it's experiment with it, see if it does break something. I mean, we're pretty confident that it, that it's reasonably efficient, but if it does, that's why it's in this experimental phase. There's a little bit of a disclaimer there. And once we have some good, implementations of it, and that we have people who are actually trying it in the real world, using it effectively and happy with it, then we'll make the next jump from moving from the experimental stage into the stable phase.
Yeah, one thing we would like in particular feedback on is whether or not existing people in the community care about JFR and other profiling formats that are subsets of what we've standardized with pprof extended. So currently the OTel has a field for including original payloads. So if you originally had a JFR that got converted into pprof extended, you can still submit the original file, because the pprof extended conversion would be lossy, and some data, potentially timestamps or other things, might not make it into the conversion. And so you can still upload the whole JFR, so you can later on either download it from the storage location where it gets sent, or the backend that you're using might be able to process this and do more things on it. And one of the use cases is this timeline view that I mentioned earlier. That's something that is likely still better done with either JFR, which is an event-based format, or for Go, there's Go execution traces, which can hold very high resolution data about what Go routines are doing. And so the spec kind of leaves the door open for acting as an envelope format for these other formats that are going to continue playing a role going forward. And we would like feedback on how much people care about these, because right now it's an optional payload that can be added to the main pprof extended payload, but the conversion to pprof extended is required according to the way the spec is currently phrased. But it could be made optional as well, and then you would only send the original files and not have to pay conversion overheads that you might not need to pay or want to pay, because you are really only interested in the original file. And that's something we would like feedback on from the community, I would say.
Yeah, that's interesting, because I guess the other signals have not shown something like that. So here, we'll have the native OTLP native, let's call it, a format that is marshaled, demarshal, whatever, encapsulated, and all of that. And you can do that in the native standardized OTel format that is pprof extended, as you mentioned. But then you say that there is at least consideration to still work with other native profiling standards that are not OTel ones, and they would skip even it won't be an addition, it will be instead of. So it will sort of relay as black box through OTel, and then the backend will still work with JFR or Go routines or whatnot, Go traces and so on. So it's interesting. That's not something we've seen so far with the architecture of OTel. So very interesting to see if this is something, because I always envisioned OTel as something that will create a unified standard that will also be obviously the enabler also for correlation and things like that. it's interesting to see if in some cases it merits separation of this kind. So happy to get some feedback. And I want to conclude before we finish this part with just getting a sense of who's involved in the project. Obviously, we talked about Grafana Labs and the Pyroscope folks and the Datadog that has a whole unit dedicated for that, Elastic that we mentioned. Just if you can name, and I know there's also quite a few end users that are involved or in the process of showing interest. Anyone that you wanted to share, that just so that the people out there at home will understand the extent of interest and involvement in the project, and also people that are also already experimenting in embedding it in their systems.
Yeah, I mean, I would say, the ones that I would say are the ones who have been involved in this process, either personally or some combination of personally or on behalf of their companies. We have people from Red Hat who have been, part of the SIG. In some of the feedback that we've received on the PRs, people from Apple, from Alibaba, from Atlassian. There's many, that have people who are interested in profiling, who have been trying to, kind of push these efforts forward. So we're hoping eBay, I guess, another one. So we're hoping that a lot of these companies that we can get some really good end user participation from them, from others. More officially on behalf of their companies, so that we can sort of like use that as evidence of, this is working. This is something that we can consider stable, that, real major companies who are, contributors in the OTel community are using successfully, so that we can, continue to spread that and get more people getting value from profiling.
Amazing. And I want to conclude with, again, saying, people out there, do join the convo, the conversation, chime in. There is the OTEP that I pasted the link before, that is merged, but you still can comment on the GitHub issue there and share your thoughts, and also follow the thread there to see the conversation has been going on. There is the SIG calls. I'm pasting here for the folks on the live stream, and I'll also put it on the show notes for the podcast, where you can find the notes from the previous meetings and the details to join the follow-up meetings, and of course on the CNCF Slack channel, #OTel Profiles, where you can join the discussion there as well. Is there any other place that you'd like people to reach out, and maybe you can share where people can reach out to you personally? Ryan, go first, and then Felix.
I would say, I'm on the Ryan Perry on the CNCF Slack. I check it pretty regularly. I would say that's probably the easiest way to get a hold of me. I'm also on the Grafana Slack if you're on there. I would say that's probably the best way is in the Slack channel. In OTel Profiles, you'll get a response from somebody, and that way everybody can kind of follow what kind of things are being requested. So I would say that's the major one. I'm going to be at KubeCon, so if anyone is watching this before, I assume this is coming out before KubeCon, right?
Live, well, everyone here on the live stream, obviously, KubeCon. Actually, this is on the news part. I'm going to mention also the event. So
sorry.
KubeCon. KubeCon.
I'll be at KubeCon. We're going to have at the just check the schedule. I don't know if it's finalized yet, but we should have a section at the OTel Observatory at KubeCon where you can come and just either ask questions or give feedback, and also for the end user working group time at the observatory, we'll have a section there where we want to talk specifically to end users about some of the things we mentioned here today.
Great. Felix?
Yeah, I would say the CNCF Slack is also a good option for reaching me, and I guess a SIG channel, that's OTel Profiles, that's the channel name. I'm on LinkedIn, I'm on the platform I continue to call Twitter, so lots of places you can reach out to me. Yeah,
and the LinkedIn and the Twitter X links I will put also. It's on YouTube. It's on. It's going to be on the show notes. So definitely check out and follow these folks. They share some interesting things there. And with that, I'd like to move to a few breaking news. We don't have much time, but I want to touch upon the upcoming community conferences. March is going to be a busy month. So we mentioned KubeCon Europe in Paris, definitely the place for the cloud native ecosystem. And specifically, there's the Observability Day co-located event, co-located with KubeCon on the first day. So check it out specifically. We're here on Open Observability Talks, so that's the day for you. This is in Europe, and then on the North American side of the ocean, there's Scale, the Social Linux Expo. That's the 21st edition with the designated track for observability as well there. And also co-located with that, there's KCD LA, Kubernetes Community Days LA. Again, a very good forum for the cloud native and open source community. And maybe last one on that side of the ocean, SRECon Americas, for more of the SRE type of conversation and audience. By the way, I'll be in California. So if you are there, catch up with me. Happy to share that. And a few notes on from the CNCF side. First, Falco project has reached graduation of the CNCF, a great milestone there. It was the first runtime security project to have been accepted into the CNCF sandbox in the first place. And that's specifically to SysDig, the original creators of the open source, and other maintainers, Amazon, Apple, IBM, Red Hat, and many more. So this is a significant milestone on the CNCF Slack. I'd like to also mention on that side CloudEvents, open specification that has reached graduation at the CNCF, the Cloud Native Computing Foundation. The spec has been adopted by Adobe I/O events, Alibaba Cloud Event Bridge, Microsoft Azure Event Grid, Google Cloud Event Rack, IBM, and many others. So it's very good to see this open specification proving obviously also by CNCF projects like Argo, Falco, Harbor, Knative, and so on. So, and this is the nice thing: open specifications, open standards. So congrats specifically for the serverless working group that is behind this spec. We talked about a month ago. We looked at Linkerd. So I don't know if you saw that. Linkerd 2.15 is out. One thing that I should mention, there's a bit of a twist there. There's a decision not to produce any more open source stable releases, the actual assets. So the open source code, of course, stays open source, Apache 2, a CNCF project. But the focus is going to be more on the dev side. The production side seems like going to be less the focus of the open source and more on the commercial side. So look at this change. It's going to be interesting to see how this plays out. And Prometheus 2.50 was released, so check out this release as well. Stopping there, Ryan, Felix, anything of that caught your eye? Any insights on any of the updates there?
That's a lot. Yeah, I mean a lot of cool stuff going on. Not much from me. Yeah, I'm really excited. I think I always love going to KubeCon and kind of talking about all these things in person with people. Yeah, so I mean that's the one that caught my eye the most. But and I get the benefit of getting to go across the pond to Paris. So I'm excited to meet everyone who's going to be there.
Sounds good. Maybe one thing that I did want to mention, we talked about eBPF quite a bit on this episode, and I saw something very interesting, a new open source tool by Netflix Engineering. It's called bpftop. It's essentially a command line tool that provides a dynamic real-time view of the performance of running eBPF programs. We mentioned quite a bit the sensitivity to performance of these SDKs, these instrumentation mechanisms, both for continuous profiling agents, but also for agents in general. And there's a lot of question about that. So I think getting the visibility and observability into the performance of the eBPF programs running on your server, on your machine, on your node is something that has been a repeating question. So very interesting. I'm pasting it here. Did any of you get a chance to look into this new tool by Netflix?
Yeah, I thought, I think today, and it looks very exciting, and I think it's much needed because with the observability industry doing a lot of things and putting stuff into the kernel with eBPF, somebody at some point has to check like how much costs are associated with adding all that instrumentation in kernel space. And this tool looks like it's a really good starting point for doing these sort of investigations and tracking down potential problems. So very exciting.
Yeah. And we've been discussing eBPF here on the show for quite some time. We had an interesting discussion on the auto instrumentation. We talked about the folks from Pixie to talk about these things. I pasted the link here. So definitely something that draws a lot of attention and from different angles. So good to see this contribution and from an end user, a big end user. And I think with that, we don't have time for more. So we'll have to conclude here. I wanted to thank Felix and Ryan. Thank you so much for joining me on this episode.
And thank you for having us. I mean, yeah, always been a big fan. Excited to be here. Appreciate it.
Yeah, thank you so much for hosting. This has been great.
Yeah, thank you. And also, obviously, great thanks for all the things that you do there in the SIG and bring us to this major milestone. So there's definitely going to be hot news at KubeCon in a couple of weeks' time. So great thing. And thank you very much for keeping on pushing forward the SIG profiles and the OpenTelemetry in general. And I'd like to thank our guests on today's show. Thank you very much for following us. As always, all the episodes are available on all your on your favorite podcast app and also on YouTube. So do check it out. And if you are listening for that on the podcast apps, do know that we stream the episodes live on Twitch and YouTube Live and also on Twitter or on X. So follow us on Twitter at OpenObserve to get the live stream times and also to stay updated with more deep dives like this one. And share your feedback as well. So I'm Dotan Horvitz. Thank you very much for listening. See you at next month's episode. And as always, may the open source be with you.